Good afternoon, everyone. Thank you for joining us today. I hope you've had a good week so far. How was your weekend? Looking forward to the hour with you. Please post as many questions as you have. We're going to walk through several problems today. And if you have any questions, be sure to let us know as we walk through the problems, and then we'll be glad to assist you. How many of you are done with school so far or at the end of your school semester? Good afternoon, Dayo. Good afternoon, Jaden. Good afternoon, Simi. Thank you for joining. So we're going to wait for a few more minutes just for more people to come in, and then we'll get started. All right, looks like we have a few more people here. Thank you for joining again. And we'll get started. I think we're at 102 right now, so we'll get started. We have second grade and third grade place value problems right now. And we're looking at two-digit numbers. We're going to round each of them to the nearest 10, and then we're going to add them together. I wanted to review this from the previous week, just so that we have a different type of example that we can work with. Okay, Simi and Jaden, thank you for your response. We'll go ahead and get started with showing you how to solve this. Okay, let's go ahead and start with this. So we have 583 and 369 are two-digit numbers, or three-digit numbers rather. They are three-digit numbers. Round each of them to the nearest 10 and add the new numbers together. So we're looking at 583, so we have 583, and we're looking for the nearest 10. So let's go ahead and put a line under the place value for tens. So that is 8 right here is the tens place value. Now we're going to look to the right of that digit, which is 3 right here. And we want to find out, do we need to increase 8 or leave 8 the way it is? In order to do that, we need to find out the value to the right of 8 must be 5 or greater for you to increase 8. If it is less than 5, we're going to leave 8 the same way it is and just replace the ones digit with a 0. So this is going to be 580. Then 369, 369. We're also looking at the tens position, which has 6. And then we look to the right. We want to find out if we have to increase 6 or leave 6 the way it is. And so to do that, we need to make sure the digit to the right is greater than, is 5 or more. So if it's 5 or more, we can increase 6 to 7. If it is less than 5, we leave 6 alone. Here we have 9, which means that we're going to increase the 6 to 7. And then we're going to leave, we're going to place 0 in the ones place. So now we have our two numbers, and then we're going to add them together. 580 plus 370, and we add this together. 0, 8 plus 7, we have 15, so we write 5, and we bring 1 up here. 1 plus 5, 6 plus 3, we have 9. So 950 is your answer, and that is correct. Looks like everyone got that right. So good job, good job. Okay, so let's look at the next question. Do you have any questions? If you do, just post your questions and I'll be glad to get back to those questions as well. So Lucy bought 6 bags of oranges. Each bag had 11 oranges. She found that there were 3 rotten in each of the first 2 bags and 5 rotten in each of the last 4 bags of oranges. How many oranges were good to eat? How many oranges were good to eat? So I'm going to give you some time to walk through this and let's see what your answers will be. All right, I see some answers coming through. So Jaden, Simi, and Anastasia here. So, okay, so we have some answers. So let's go ahead and try to attempt these questions together. So what we have here, we have 6 bags of oranges. So let's go ahead and try to, I'm going to just try to draw 6 right here, 6 of them. We have 6 bags of oranges, and here we have 11 oranges in each bag. We have 11 oranges in each bag right here. And so, how many oranges do we have all together in all the bags, regardless of whether they're good to eat or not? That's going to give you 6 multiplied by 11, which is going to give you 66, or you can add 11 6 times. By the time you get to 4th grade, you shouldn't really have to use this other method because it's gonna take more of your time to do. So you can add 11 6 times, or you can just multiply 6 by 11. That will give you the total number of oranges that you have together. And now we found out that there are 3 rotten oranges in the first 2 bags. So in the first 2 bags, there are 3 rotten oranges, so that's going to be 6. And then in each of the last 4 bags, we have 5 rotten oranges in them, and that's going to give us 20 oranges. So what we need to do to find out how many are good to eat, we need to find out the number of good, or the total number of oranges. Let's write that properly. So let's say here, good oranges will be equal to total minus rotten. Okay, so let's find out how many we have that are rotten. We have 6 from the first 2 bags and 20 from the last 4 bags. That's going to give us 26. And so we want to find out how many we have that are good to eat. We're going to have, so the good oranges will be 66 minus 26. So we're going to go ahead and work that out. And we have 66 minus 26. 6 minus 6, we have 0. 6 minus 2, we have 4. So we have 40 good oranges. So we have 40 good oranges. Good job, everyone. Everyone that attempted it got it right. So good job, good job. Are there any questions about this topic? Are there any questions so far? Any questions so far? Shewano, okay. Shewano. Okay, I'll remember that. Okay, let's go to the next one. For our fifth graders, what we have here is we have three different points, and we want to first plot these points on the graph. We want to join the points together and see what shape that is going to give us. So I want you to go ahead and try. Tell me where. Okay, we can actually work through this together because you don't have your own graph, so we can walk through this together. So we have 3 points. We have this point. We have the point 3, 3. We have 3, -2, and then -2, -2. So what we're going to do is, remember what I showed you last week, is just have x, y, so that you know that the first one is x and the second one is y. First one is x, second one is y. So we're going to now try to plot this on a graph. So we look for 3, 3. So we're looking for x is 3 and then y is 3. So you see x is 3. Remember what I showed you last week? You can draw a line across, you can draw a line up, and then where those lines meet is where your point is. So this is your point 3, 3. The second one is 3, -2. So we have 3 here. So we draw a line. Okay, we can draw a line downwards because we know it's -2. We're going to go all the way here. So you can see our point is going to be right about here. If I had drawn a straight line, it would be right about there. And the other way, the last point we have is -2, -2. So we have -2 here. Starting here, we go down all the way, and we have -2 right here. So the one way you can look at it, another way you can look at this point is, if I start from 3, I can say I'm starting from 3 and I'm going up 3 units because it's a positive value of y. So we start at 3 on the x and I go up 2 units. And then for the second point, I start at 3 and I go down 2 units. And then for the last point, I start at -2 and I go down 2 units. So there are lots of different ways you can actually try to come up with your approach. And as you walk through this topic, you'll find an approach that works the best for you. So feel free to explore different ways to arrive at this point on the graph. So now we're going to try to join them together and see what shape we get. So we have this right here. We have this right here, and then we have this point. So we have something that looks like a triangle. So this is a triangle. This is a triangle. So we have a triangle here. Does this make sense to you all? All right. Shewano, good job. Good job to you all. Jaden, good try. So we have a triangle here. Does this make sense? All right. Looks like we're doing good. We're doing good today. So let's go ahead and move on to the next question. In this question, we're going to be dealing with probabilities. So we have a fair die is rolled. What is the probability that the number on the face of the die is a prime number? What is the probability that the number on the face of the die is a prime number? What is the probability that the face on the die is a prime number? So this is for our 6th and 7th graders. It's important to understand what the probability is. Probability means what is the chance that this is going to happen? What is the likelihood that this is going to happen? How possible is it that this will happen? So those are the different ways you look at probability. So we want to first find out, in a fair die, how many possible choices do you have for the numbers on the die? So the numbers on the die are usually 1, 2, 3, 4, 5, or 6. So these are your 6. These are the choices you have for the number on a die. So now we want to find out what is the probability. So let me explain to you what probability is. The probability that an event happens is the possible chances divided by the total chances. Okay? So this is going to be possible outcomes divided by the total number of outcomes. All right, so let me show you what that means in this case. What we're going to be doing here is we're seeing that there are 6 possible numbers that could show up on a die. So we have a total of 6 possible numbers that could show up on the face of a die. Now we want to find out what is the probability that the number that shows up is a prime number. The first thing you want to do is identify your prime numbers. What are your prime numbers? Actually, I'm going to throw this out to you. Which of these numbers from 1 to 6 would you consider to be prime numbers? Let me throw this out to you because I want to check for something. Which of these numbers would you consider to be prime numbers? I'm going to give you a few seconds to think about it. Remember, you have to remember what a prime number is to answer that question. Which of these numbers would you consider to be prime numbers? I'm looking to see if I'm going to get some responses. Okay. Okay, that's some of them. Shawana, that's some of them. Okay, I see. All right, so to understand this, we need to know what a prime number is. What is a prime number, you may ask? A prime number is a number that has only 2 factors, 1 and itself. And because of that, 1 cannot be a prime number. It has only 1 factor. So the prime numbers we have here are actually 2, 3, and 5. If you look at 2, it has only 2 factors, 1 and 2. This has only 2 factors, 1 and 3. This has only 2 factors, 1 and 5. If you look at 1, it has only 1 factor itself. So that's why 1 cannot be considered as a prime number. It's not a prime number. So now what we have for this event here is we have 3 possible chances. The probability that this event happens is that we have 3 chances that it happens, and we have a total of 6 possible outcomes on the die. So this is going to be your probability, and you're going to simplify this, divide this by 3, divide this by 3, and it's going to be 1/2. One thing to know about the probability is your probability can never be less than 0. It can never be greater than 1. If a probability is 0, it means that there is no chance that that event can ever occur. For example, if I said to you that we have a die, what is the probability that the number on the face of a die is 7? You know that your die is from 1 to 6, so you know that 7 can never happen. So the probability of getting a 7 will be 0. Now, if you have probability of 1, it means it will always happen. An example of that would be, what is the probability that the number on the face of a die is any number from 1 to 6? You can see that they're all 1, 2, 3, 4, 5, and 6 are possible outcomes. So therefore, you know that that will always happen. And so those are your extremes, your 0 and your 1, and everything else is in between that. So that's what probability is about. If you have any more questions on this, I have some examples on the YouTube channel. Go ahead and take a look at some of those, or just if you have questions, you can send them to us by email, or you can post on our Facebook page, or you can send it through Twitter or any other means that you may want to send it, and I will be glad to help you out with that. All right. I hope this makes sense to you. 6th graders, 7th graders, even 5th graders, I think you can understand this. If you have any questions, let me know and then I'll be able to go over it again. All right, let's go to the next one. We're looking at fractions. We're looking to complete the boxes with the missing fractions here. And this is similar to a question that came through last week. I just wanted to make sure that we address them. If your question is not addressed, I will take some time to address some. I'm going to take some time to walk through some other problems that are not here that I think will be helpful to you as well. So complete the boxes with the missing fractions. We're looking for what fraction will be in the boxes that we see here. Remember that your boxes are going to have mixed numbers because your mixed numbers will be any number that is greater than 1 that has a fraction attached to it. So you have a whole number and you have a proper fraction. That's what makes up a mixed number. So we need to find out what the mixed numbers would be in these squares that we have here. So I'm going to wait for a few seconds to see if you all can come up with the fractions, and then I'll show you what to do. All right, so let's see. Remember what I showed you last week? You have to think about, count the number of spaces. So you have these spaces right here. So you have 4 spaces between 2 and 3. So you're going to divide, because between 2 and 3 you have 1 unit. So you have 1 unit and you have 4 spaces here. So we're going to divide this, and the box here, or the square, shows up on the 3rd space. So you have 1, 2, and 3. So you have 1 over 4 here. You have 1 over 4 here. You have 1 over 4 here. So you add this together, you're going to have 3 over 4, and then our whole number is 2. Okay. Good try, good try. I like the fact that you're trying, so it doesn't matter if it's right or wrong. I just want to see that. I want to see how you're thinking about these problems. Okay, then the next one, we have three spaces between 3 and 4. So we divide it by 3, so you're going to have 1 over 3 here, 1 over 3, and then 1 over 3. And so you have your whole number is going to be 3, and then you get to this square after your first space. So it's just going to be 1 over 3. And then for the last one here, you have 1, 2, 3, 4, 5. So you have 5 spaces here. So each space is going to be a fifth. So you divide 1 into 5. So let's go ahead and divide it this way. So you divide 1 into 5 different units. So you're going to have 1/5 right here, 1/5, 1/5, 1/5, and then 1/5. So you have 5 of them to make 1 unit. So where does this square come up? It comes up after the 3rd space. So 1, 2, 3. So you're going to have 3/5, and then you have your whole number is 4. Always remember that your whole number is going to be the same as the number on the left, the number you're coming from, because the number 5 is greater. So your whole number here cannot be 5 because you're not at 5 yet. So that's really how you want to go ahead and get these values. When you have a number line with whole numbers and you want to find the missing fractions, in this case I've dealt mostly with a space of 1 unit. You could actually have 4 units between each of them, and then you'll have to use your understanding of fractions to also come up with this. I think I'll probably try something like that next week, where instead of 1 unit we have 2 or 3 units, and then you have to add your fractions up to get to your missing numbers. All right. Are there any questions on this? Okay, so if we don't have any questions, let's go ahead to the next problem. So our 4th and 5th graders, we're looking at converting measurements, and we're going to convert this length to inches. We convert 5 yards to inches and then 2 feet to inches. Convert 5 yards to inches and 2 feet to inches. If you have any topics that I've not covered that are of interest to you, feel free to let me know right now. We have some time to address your questions or your topics. So feel free to let me know what those topics are going to be, and then we'll try to walk through those topics. Or if there are topics that we've gone through already that you want some more help with, also let me know, and then we'll also address them. So we want to convert 5 yards to inches. We want to also convert 2 feet to inches. So 4th and 5th graders, this is for you. Let's see what our conversion units are. 12 inches, we have 1 foot. We have 3 feet will make 1 yard. So 12 inches make 1 foot, and 3 feet will make up 1 yard. So that should be all that you need to answer these questions. So we're trying to convert I'm waiting on some 4th and 5th graders to respond. 12 inches will make up 1 foot, and 3 feet will make up 1 yard. Here we're trying to convert 5 yards to inches. We're also trying to convert 2 feet to inches. So let's give you a few more moments, and then we'll proceed. Okay, so we're not having any responses yet, so let's go ahead and solve this together. So we have 12 inches in 1 foot. So let's figure out how many inches we have in 1 yard. So we have 12 inches, 1 foot. So 1 foot. All right, Jaden, okay, good responses. 1 foot, we have 12 inches. And then we have 1 yard, we have 3 feet. Okay, so now we're going to convert this part right here to inches. So 1 foot is 12 inches, so 1 yard is going to be 12 multiplied by 3 inches, which is going to give us 36 inches. Now we're going to convert 5 yards to inches, so 1 yard is 36 inches, and then 5 yards right here will be 36 multiplied by 5, and that is going to give us, let's go ahead and multiply out right here. 6 multiplied by 5, we have 30, so we write 0 and we bring 3 up here. 3 multiplied by 5, we have 15, we add 3 to that, we have 18. So therefore 5 yards is going to be 180 inches. And then the next one, we have feet. So we have 1 foot will be 12 inches. 2 feet will be 12 multiplied by 2 inches, which is going to give you 24. So therefore 2 feet will be 24 inches. Any questions? So that's really how when you have this type of problems, when you have to convert from one form of measurement to the other, you want to always use this breakdown. You have to think about it this way so that you can understand how your measurements fit into each other. And so if you have any questions, let me know. If you want us to do some other examples, maybe if you want us to do something on volumes or weight, we can also do that as well. Okay. We're going to do some fractions. So I like to always do some fraction problems because I know that fractions, this topic is one that follows you for a long time, and if you don't understand it now, it could actually hurt in the future. So I always want to bring it up so we have several opportunities to review how we add fractions, subtract fractions, multiply fractions, and divide fractions. So if there's anything that you need, any kind of examples that you need for us to walk through, feel free to let us know so that I can bring it here and show the whole group how these questions are solved and the easiest ways to go about solving them. Some way that will make sure that you don't forget and that you can do them on your own. That's the most important thing about math, is learning so that you can actually go back and do some other examples on your own and get them right. Simi, you're talking about the topic on converting measurements? Okay. All right, let's finish this. We'll have time to do some more measurements. After we finish fractions, we'll do some more measurements. Okay, let's get these fractions done, and right after we'll do measurements, and after that we'll do our puzzles for the day, and that should be it. But while we're doing measurements, if someone else has a different topic that they would like us to look at, feel free to let me know, and then we'll also create some time for that as well. All right, let's go ahead and subtract these fractions, and then we'll divide the mixed numbers. So we have 5/7 minus 2/9. 5/7, 5/7 minus 2/9. Remember, when you're dealing with addition or subtracting fractions, you always have to have the same denominator before you can do anything with your numerators. Always have the same denominators. If your denominators are not the same, you have to find a way to make them common. So you have to find your least common multiple or least common denominator of your existing denominators to arrive at a common denominator. So let's try to solve this together so that we can address some other concerns. So what we're going to do here is we're going to convert this. We have 7 here and we have 9 as your two denominators. We can't work with them in this form. We have to convert them to a common denominator. The easiest way I'm going to do this is we're going to multiply 7 by 9, which is going to give us 63. So now we have to convert this to fractions, so we have equivalent fractions with a denominator of 63. So now we have 5/7, and we're going to multiply 7 by 9, and so we multiply 5 by 9. That is going to give us 45/63. And then we have 2/9. We're going to multiply 9 by 7 and then multiply 2 by 7. That's going to give us 14/63. So now our question becomes 45/63 minus 14/63. So now you can see that these are common denominators. We have common denominators now, so it's easy to subtract your numerators. So this is going to be 45 minus 14/63. And now we can subtract 14 from 45. So 45 minus 14, that's going to give 5 minus 4, 1, 4 minus 1, 3. So this is going to give you 31/63. Now when you get to this point, you have to ask yourself if this is the simplest form. Do you have any common common factors. If you have common factors between 31 and 63, then you have to continue to reduce them until you can no longer reduce the fractions. But here, 31 is a prime number. Remember, we talked about prime number earlier. It has two factors, 1 and itself. So 31 has only two factors, 1 and 31. And 63 has common factors that it has several factors, and so they don't have common factors. The only common factor they have is 1, which you don't have to do anything with once if that's the only common factor. But 63 has many other factors, so you can see here that these two numbers do not have a common factor that is greater than 1, so we leave it the way it is. Questions? All right, Simi, good job. All right, good. Now the last bit of it is division. What we're going to do here is I want you to remember that whenever you have mixed numbers, you always have to write them in improper form. You have to convert all your mixed numbers to improper fractions. So your 3/3/5, 3/3/5, and 4.5 must be converted to mixed numbers for you to be able to work with them. So the first thing we're going to do here is convert 3/3/5 to an improper fraction, They're already mixed numbers. We have to convert them to improper fractions. So let's go ahead and do that. Okay, so 3/3/5. 3/3/5, we're going to convert this to an improper fraction. So we multiply 3 by 5, which is, we multiply the whole number by the denominator. So 3 multiplied by 5, we have 15. We add the numerator plus 3, that's 18/5. And then in this case, we have 4.5. We multiply the whole number by the denominator. 4 multiplied by 2, we have 8. We add the numerator, 8 plus 1, we have 9/2. So this question now becomes 18/5 divided by 9/2. And remember the rule. The rule is that whenever you're dividing, you leave the fraction to the left of the division alone. So it's going to be 18/5. We change the sign to a multiplication, and then the fraction on the right, the numbers switch positions. So the 2 now becomes your numerator, and the 9 becomes your denominator. So that is 2/9. So now we can multiply across and simplify, or we can just go ahead and divide diagonally. So 9 divided by 9, we have 1. 18 divided by 9, we have 2. So this is going to give you 2 multiplied by 2 divided by 5. Okay, semi-good. 5 multiplied by 1, so this is 4/5. Always remember, whenever you're solving fractions, as much as you can, you have to convert it to its simplest form. You have to convert it to its simplest equivalent form. Okay, so what you did was fine. What you did was 18 multiplied by 2 divided by 5 multiplied by 9, which is 36/45. And the next thing you had to do there is divide both of them by 9, so you can get 4/5. So that's what you would do here. But you're on the right path, and you're making a lot of progress with your understanding of fractions, so that's good. So now that we have some time, so if there are any questions that you have, please let me know. And we are going to go ahead and look at some more questions on converting measurements. So let's let me just come up with some examples here. Convert (36) yards to feet. And then the second one we're going to do here is convert 45 inches to yards. Let's try that. So we're converting 36 yards to feet. and we're converting 45 inches to yards. So I always like to start off this way. I have yards and feet. I know that 3 feet will be equal to 1 yard, and I am going to need, this is unknown right here, I'm going to need to know what is going to give me 36. So how many feet will give me 36 yards? How many feet will give me 36 yards? It's pretty simple to see. So what you're going to see here is, one of the ways I like to do this is, if you look at these two numbers here, you can see that you can multiply this by 36. So 1 multiplied by 36 gives you 36. You can also multiply this by 36 to give you your value here, which is 36 multiplied by 3. 6 multiplied by 3 is 18. We write 8, bring 1 up here. 3 multiplied by 3, 9 plus 1, we have 10. So that's going to give you 108 feet. So you can see that here, that this is ratio. When you create proportions or when you create ratios here, the other way you can look at this is that you have 1 here, you have no value here, you can just multiply across. In some approaches, what they end up with is they can say something like this: 3 over 1 is equal to x over 36. So there are lots of different ways. As you go further in your math, you'll find out I could probably think of about 4 or 5 ways to do this, but this is the easiest way, I think, at the 5th grade level for you to be able to do this. All right, Shay, good job. Thank you for coming. Thank you for joining. I don't think I've seen you before, so thank you for joining. I appreciate your time, spending time with us. And we have one more. And Sim, if you have more questions after this, just let me know. We have some time. If I can do maybe 1 or 2 more after this one here. So we want to convert 45 inches to yards. So we're going to look at, we have inches and then we have yards. So let's go ahead and start from 12 inches. We'll make up 1 foot, and 3 feet will make up 1 yard. So we need to find out how many inches there are in 1 yard. So like I showed you earlier, we have 3 feet in 1 yard, which means we have 3 times 12 inches. Okay. Shay, you tried. I want you to think about it differently though, because you're just multiplying. I want to show you something here. So this is going to be 1 yard. So what we now have is we have 36 inches will be equal to 1 yard. So we want to find out how many yards there are in 45 inches. So 45 inches will give you how many yards? We don't know. So the best way to go about it is, in this case, whenever you're going from a bigger measurement to a smaller measurement, you multiply. Whenever you're going from a smaller measurement to a bigger measurement, you divide. That's the trick. So let me say that again. If you're going from a smaller unit of measurement to a larger unit of measurement, you are going to divide. But when you're going from a larger unit of measurement to a smaller unit of measurement, you're going to multiply. So if you look at this example here, yards are larger than feet. So we're going from 36 yards to feet. So we're going to multiply because we're going from larger to smaller. Now we're going from smaller here, 45 inches, to yards. So we're going to divide. So this is going to give us 45 over 36. 45 over 36. So just remember these rules, and this rule applies regardless of what unit of measurement you're using. Now we're dealing with length. You can apply it to volume, you can apply it to weight, you can apply it to time, going from hours to minutes or minutes to days. So these methods will work regardless of what you're doing. So now we have 45 inches is 45 over 36 yards. So now we're going to simplify this fraction. So let's go ahead and divide 45 divided by 9, 36 divided by 9. So therefore we can say 45 inches is equal to 5 over 4 yards. Or you can actually go ahead and convert 5 over 4 to a mixed number. So that's going to be 1 over 4 yards. How did we get that? Let me not skip that step. So we have 5, 4. How many groups of 4 do we have in 5? Just 1. 1 multiplied by 4, we have 4. We subtract these numbers and we have 1. So this whole number here, 1, represents your quotient. Okay. And then this one up here represents your remainder. And then the 4 is your divisor, which is your denominator. So that's how we come up with 1 over 4 yards. I hope this makes sense to you. I hope it makes sense. I hope it's been helpful. So don't forget, just whenever you have a topic that you want us to address, send them to us. At the end of this session, I'll show you all the different ways you can reach us, and just let us know. We'll be glad to bring these questions out to the front and try to solve as many as possible. At least as many as time will permit us to solve within our 1 hour span. Okay. All right. Are there other ways to find the answers? These are the best ways to go about it. So once you understand that when you're going from a larger unit of measurement to a smaller unit of measurement, you multiply. So let's do it this way. Larger unit to smaller unit. You are going to multiply. And then if you're going from a smaller unit to a larger unit, and when I say smaller unit or larger, I'm talking about the measurement, not the actual number, the measurement. So smaller unit to larger unit, we're going to divide. So this rule applies. It works all the time. This is one method that works all the time. All right, so now we have a few more minutes. I'm going to allow you all do some puzzles. If there are no other questions or no other topics that are of interest to you, I'm going to go ahead and do some puzzles. So I'll give you a few seconds to let me know if there are other topics that are of interest to you. We can do 1 or 2 problems on those, and then we can go ahead and address or attempt our puzzles. You're welcome, Simi. Thank you for always joining. Thanks for inviting your friends as well. Okay, so let's go ahead and do some puzzles here. So we have symbols today. So if 4, we got a star. 2, period 2 is equal to 4. And the same for 3, 5, and 5. 6, 2, and 3. 3, 8, and 6. What is going to be 9, star 8, period 4? What is 9, star 8, period 4? I guess you can call that a big shaded circle. Okay, so let's go ahead. I'm going to give you some time to think about this. It's actually not complicated. I tried not to make it complicated. I'll just give you a hint. The star represents an operation, and the circle represents another operation. 15. You're actually very close. Very close. Very, very, extremely close, actually. While you all are doing the puzzle, are there any of you that are still, how many of you are almost done with school or still have some time in school, or actually maybe this is your last week of school? How many people are in any of those situations? When are you done with school? You all are quite close. You are all very close. Okay, okay. So somewhere ending in June. All right. I know where we are here, our school district. Well, we have a few school districts around us, but one of them is done this week. The other one is done in June. So I understand. Okay. All right. Let me give you a hint. This star here represents addition. This period here represents subtraction. So the star represents addition and the circle represents subtraction. So that should give you a hint on, that should probably guide you to your answer. If you can address that, that will give you your answer. So 4 plus 2 is 6, 6 minus 2 is 4, 3 plus 5 is 8, 8 minus 5 is 3, 6 plus 2 is 8, 8 minus 3 is 5, 3 plus 8 is 11, 11 minus 6 is 5. There you go, Shay, good job. Okay, so we got, that's good. So we got a good answer so far. So our answer is going to be 9 plus 8, which is 17, minus 4, which is 13. So that's a good answer. So you're saying division for star and dot for addition? That would be very difficult with 6 and 2. If you're saying, well, it won't work. I don't think it will work for all of them. So good job, good job. All right, so let's go to the last one for today. So we have this sequence. I try to do something like this for you guys every week because I change the sequence and I change the rules for the problem that we just came from. I try to change it around. So here we have 28, 21, 24, 18, 20, we have a missing number, and then we got 16. 18, that's a good try. I think you're not actually far from the answer. You're not far from the answer at all. $15. That is fantastic. That is fantastic. 15 is very correct. So let's see what everybody else. Can you explain your answer? If you can just write a little bit about what you thought about to get your answer, that would be very nice. So Shay, you're right. I'd like to just get your thoughts on how you arrived at your answer, because I'm curious actually. Okay, so we're almost okay. Very good, very good, very good. Good thinking, good thought process. That's good. So when I was coming up with this puzzle, here's what was at the back of my mind. But you got the answer just in a different way. But I think your thought process is fine. What I thought to myself was 7 multiplied by 4, 7 multiplied by 3, 6 multiplied by 4, 6 multiplied by 3, 5 multiplied by 4, 5 multiplied by 3, then this is 4 multiplied by 4. So your thought process is fine. So you have 28 to 24, 24 to 20, 20 to 16, then you have 21 to 18, then 18 to 15. So that's so 2 different ways to get at the answer. So that is really good. Thank you all for your time. Are there any questions before we end the session today? Are there any questions? Any thoughts, any comments that you want to share? And then if you don't have any, we can end the session today. And I want to just thank you. I always appreciate when you all come on. It's very nice to have your support. And I actually enjoy learning. I enjoy learning, and even the questions that you all ask, sometimes they make me think about, okay, I understand how these students are thinking about things, and it's very good for me because it helps me. Even as I make videos, I try to factor in the way students think about problems. And so I like to thank you for always for your attendance, for your encouragement, and for joining. And if you have any questions or any thoughts, any comments that you'd like to share, feel free to send it to us by email, info@mathis.com. You can also go on our website and leave a comment, mathis.com, or you can send us a text or WhatsApp message or call us at 240-688-5447. So I appreciate you, and I hope you enjoy the rest of your week. For those of you that are about to end your school semester, I hope you spend your summer getting caught up on your current school year, because I know most schools did not finish, and also start thinking about preparing for the next school year, because we don't really know what school is going to look like in August and September. As usual, we're here to help you with that. If you need anything, just feel free to reach us in any of these ways. Have a good rest of your week. And for those who have siblings that are older in 8th to 12th grade, let them know that on Thursday we'll be here at the same time to help them out. And otherwise, have a blessed week. Enjoy your weekend. And I'm looking forward to our time together next week. Bye and be blessed.